Moving on to proposition 24. If two triangles have the two sides equal to two sides respectively, but have the one of the angles contained by the equal straight lines greater than the other, they will also have the base greater than the base. So what is he saying? He's saying that if we have two triangles, here and here, let's say this side is equal to this side, and this side is equal to this side. He's saying that with respect to this other triangle, if this angle right here is greater than this one, then it follows that this side is greater than this side. So that's the claim. And now let's check out the setup. Let ABC and DEF be two triangles having the two sides AB and AC equal to the two sides DE and DF respectively. So let's draw those out. So here we have, let's say this one is ABC. And let's say we've got the other one. That's going to be our DEF. And he's saying it's also given that AB is equal to DE and AC is equal to DF. Namely, AB to DE and AC to DF. And let the angle at A, which is this angle right here, let the angle at A be greater than the angle at D. So that's the setup. And he claims, I say that the base BC is also greater than the base EF. So that's the claim. And now we proceed to prove this. Next he says, for since the angle BAC, which is this angle up here, is greater than the angle EDF, the angle at D, let there be constructed on the straight line DE, so on the straight line DE, and at the point D on it, the angle EDG. So we're going to make an angle ED to G, but he's going to construct this in such a way that the length is equal to AC. So we're going to bring this over to G. Let's say right about there. That's going to be our point G, such that this angle here at A is going to be equal to EDG, and also that DG is going to be made equal to AC, which is in turn equal to DF. Just to review this, let DG be made equal to either of the two straight lines AC or DF, which we've done, and let EG and FG be joined. So lastly, we're going to join E over to G and F and G. Next, we're going to do a little bit of reasoning about this triangle ABC and the triangle DGE. And let's see what he says. He says, then since AB is equal to DE, that side of the triangle, and AC to DG, the two sides BA and AC are equal to the two sides ED and DG respectively. And he notes that the angle in between, BAC, and the angle BAC is equal to the angle EDG. So this angle and this angle are the same also. And from this it follows that the base BC is equal to EG. And that follows by proposition 4. Remember the equality of the bases falling from side angle side, equality of triangles. Next, we're going to reason a little bit about this triangle DGF over here, which you'll note is isosceles. He says, again, since DF is equal to DG, DF is equal to DG, the angle DGF, which is going to be this angle right here, is also equal to the angle DFG. DFG. So he's saying that these two angles are equal. And that follows from proposition 5. Next, let's have a look at this angle EGF. Notice that EGF is a part of the angle DGF. So EGF is a part of DGF. Hence it follows that EGF is lesser than DGF, but DGF is equal to DFG. And from that it follows that DFG is greater than EGF. He says, therefore, the angle DFG is greater than the angle EGF. Now, if we have a look at DFG, which is again over here, DFG is a part of EFG. So it follows that EFG is greater than DFG. So we can rank that as well. So greater still than DFG is EFG. And from that it follows that EFG is much greater than EGF. Hence he says, therefore the angle EFG is much greater than the angle EGF. Next he says, and since EFG is a triangle having the angle EFG, so let's also highlight this triangle over here, EFG. Notice it has the angle EFG, which we said EFG is greater than the angle EGF, from which it follows that EG is greater than EF. But also recall that EG is equal to BC. Therefore, it follows that BC is greater than EF. So BC is greater than EF. This side here is greater than that side there, which is what we intended to prove. And that follows from proposition 19, that the greater angle is subtended by the greater side. Hence he says, and the greater angle is subtended by the greater side by proposition 19. The side EG is also greater than EF, but he reminds us that EG was equal to BC. Therefore, BC is also greater than EF. This side is greater than EF, and that's the proof.